So I'm the Deputy Director of what's called the Faraday Battery Challenge. It's a £330 million programme for the UK government for us to become world leaders or world class in battery technologies. It fits into UK research and innovation. I sit in Innovate UK. And really there's a small group of us within UKRI, but we are partnered alongside something called the Faraday Institution, which is a fantastic group of similar numbered people who are pulling together the academic research and working alongside around 450 researchers. In our area, we cover the collaborative R&D, and that's the mid-TRL, mid-technology readiness. So we work with everyone from SMEs through to large multinational companies like JCB or Johnson Matthey or Jacqui Land Rover or Nissan. And we pull together a portfolio of innovation projects, which helps us leap forward using the science breakthroughs from the Faraday Institution into sort of the mid, sort of taking up to prototype level. We develop prototypes, or the companies develop prototypes with us, all the way through to then commercialization. And we have a pillar called the UK Battery Industrialisation Centre, and that's a £130 million programme. There's about 100 engineers. It's located as a facility. It's located next to Coventry Airport. And actually that takes prototypes and runs them through a facility that has full manufacturing rate equipment. It means that you can produce batteries sort of at the ton scale. So if at laboratory level, it's at the gram scale. If at collaborative R&D, it's sort of at the kilogram level. They produce at the ton scale. And that's really important because actually Gigafactory runs at the sort of kiloton scale. And what it means is you can run trials, you can run pre-series batteries, you can change your chemistries within cells, you can trial different shaped cells, for example. And actually all that adds together to create a landscape in the UK that's very exciting if you're developing the batteries for the next generation of technologies for electrification of vehicles. Oh, my career's been, it's a bit of an interesting one, really. I started on the steelworks as a manufacturing and materials engineer. I'm a metallurgist by background. I did 10 years on 3 out of the 4 steelworks in the big steelworks in the UK, integrated ones. I then went to work for the Environment Agency for 14 years, and I regulated heavy industry from an environmental perspective, particularly pollution and such as air quality and water releases. And then I came here, and I guess these are the ones you want me to talk about. I stepped into Faraday in 2017, and there was only a small group of us. And I'm delighted that we were asked to sort of get this £246 million programme, as it was then, off the ground and bring together a team of people alongside. And that has been such a learning curve for the last 4 years. It's been such an exciting thing to be part of and to be driving forward. That initial getting the Faraday Institution set up, the UK Battery Industrialisation Centre consortium sponsored, getting the first CR&D competition off the ground. That was a fantastic sort of achievement in a very short space of time. And I think when I look back, now the bit I'm most proud of is just the excitement that is around the UK from global perspectives. We've sort of really focused inward on the UK and what we can do together as a team within the UK. And actually, there's not many countries in the world where you can go, it's not a one-stop shop, because that would be pretty much impossible, but you can come into the UK and you can navigate this new and emerging industry very sweetly. The teams that are around the place, we know each other. We're building things like the Innovation Hub on the Knowledge Transfer Network. I'll give it a bit of a dig. Definitely sign up there, go and see who else is working in this space. But equally, I think if you came in wherever it was from the world, you'd find your way to people that are either within the team or just one sort of step away from us very quickly. And it makes it very easy then to navigate. And I think that excitement around Faraday, it's got to be one of my biggest achievements. And I think the fact we've done that in spite of, COVID, the initial uncertainties around Brexit, there's been a real feeling throughout of purpose and a Team UK. And if that's something that we've done, I'm exceptionally proud of that. And I guess the other bit that just is close to my heart, I touched on being part of the Environment Agency, doing things in that really pull together the sustainability of batteries, but across all the government departments that need to be involved. So we have, there's a load of officials behind the scenes really looking at what it means for the Department for Transport, for BEIS, so the Department for Business, Economics and Industrial Strategy, what it means for DEFRA, the Department for Environment, Food and Rural Affairs, you know, all these people within main government departments, within regulators like the Health and Safety Executive, Environment Agency, all really pulling together to enable this transition to go very, very quickly. That, I love the fact that we've been at the heart of that, and I'm very proud of those things. So the 2030 EV target is a part of the government's net zero pathway. I don't know if you've seen the sixth carbon budget that Boris Johnson has stated that on the 20th of April that we were going to also legislate into the UK. So the 2030 element of that is really surface transport and how it plays into it. And so there's this brilliant route now to net zero. We've actually got probably more clarity than we've ever had on how to actually get to a position in this country that we're not contributing to climate change. So the funny thing is, what we do in Faraday is actually to look at surface transport and to look at cars and vans and off-highway and mining and rail and the batteries that are needed for those applications. And we're really here to see how the UK can prosper from that transition, that we're not just buying in net zero technologies, that we're actually at the forefront of them. So when we started, people really talked about the Far East, for example, for supply batteries, for cells, for lithium ion. And actually now what you're looking at is the next generation batteries like solid state. Well, actually, those could be UK manufactured. You could get to a point now where, because of the research and the development and the excitement around the UK, that we could be an active player in that. And that's the piece that we're really here to make sure the UK prospers from. And it's a complex landscape. It's not just about winning for solid state or for the next generation, such as lithium sulfur or sodium ion. It's actually all the components within the cells and the batteries. And we have some fantastic work going on in sort of the predictability models that you have for battery management systems. We have some fantastic research going on thermal management, on actually all the different cell materials that possibly could be used, using AI to predict some of those different chemistries to speed it up in terms of finding those optimum ones for different applications. It's a huge area. And actually, for me, that's really our role, is to make sure that as we transition away from internal combustion engined vehicles, which the UK is really strong at, we make more engines than we do cars in the UK, that actually we've got an opportunity to not lose that knowledge around propulsion, but to actually be able to manufacture the cells and battery packs that go into those vehicles of the future. So we've been funding that 330 million has gone into many different areas. When you look at the Faraday Institution, they've sponsored work into recycling, into multi-scale modelling, into battery degradation, into battery safety. There's 10 projects in all, very large scale projects in the Faraday Institution that they've sponsored. When you look at the collaborative R&D projects, there's around 130. We're about to announce some more, so that's the around projects. And we've sponsored from sort of over half of it has been into cell chemistries, but we've also heavily invested into modules, packs, battery management systems and thermal. We've all invested into recycling and reuse. Safety has also been a significant area that we've invested in, and then also diagnostics. So what you've seen is you can see across those two funding streams in Faraday Institution and in our CR&D that we've really sort of pulled together to bring forward technologies that actually help us meet the requirements of batteries. So we work mainly to 8 key targets, and those targets are cost. You know, people always worry about what electric vehicles cost and who's going to be able to afford them. Actually being able to produce and manufacture new technologies at scale really efficiently and cost effectively is a really big advantage for the UK. We worry about the energy density and the power density. We worry about the safety and the first life. And first life means a lot to me, not just because as a consumer, I might already have an 8-year warranty on my battery in my electric vehicle, but actually if I can have a battery that lasts longer than that, then actually my impact on the environment comes down even further. So the longer the first life, it's a significant improvement on environmental impact. We worry about the temperature range that these vehicles operate at. We know at low temperatures and at high temperatures, we can have issues in getting the same performances. And we worry about predictability. You know, electric vehicles have got about 120 years to catch up on the diagnostics that you have on your internal combustion engine. And actually a goal of ours is to really develop more predictable mechanisms by understanding better the electrochemistry, but also the cycling and the life cycle through those 8 to 12 years of your electric vehicle. And the last thing we've invested in has been the sustainability aspect, particularly recycling and reuse projects. So for me, it's that whole area of what do lithium-ion, advanced lithium-ion, and what do next generation batteries have to deliver for batteries to be really acceptable as a mode of a propulsion system for transport. What's really interesting is how do we, for every application, you could almost have a bespoke chemistry, a bespoke battery pack. And actually that's not very cost effective. So you can see how that we're always sort of aiming to enhance one element of those of what batteries need. And you can always normally do that at the expense of cost or anything else, right? So what we've been doing is actually getting people to work together. So I talked earlier about the Battery Innovation Network. What that actually has is a report in there where for different applications for battery transport, actually some of the synergies. So when you look at take a motorsport battery and compare that to what an off-highway application, such as a small or medium-sized JCB might need, and you start to see that a Formula E car battery and a small JCB might have very similar demands, lots of power, but a relatively short range or lifetime, not lifetime, how can I put it, life on the battery before you need to recharge it. And actually that works, right? So you start to see how this really clear understanding of duty cycle and the application can bring forward clusters of applications that battery manufacturers in the UK and researchers and innovators can really focus towards. So joining up all of those sorts of nuances so that we can commercialize is fantastically important. The other area that we then work is trying to work with investors so that they understand this really complex space. It is hugely difficult to just sort of go, oh, I know batteries. And so when we sort of work then, it's like, how do we go, how do we explain all of this for investors? And so we're doing some work where we help our companies pitch better and explain better, but equally seeing how we can describe and inform and make sure investors are more comfortable with that. And you'll see us sort of publishing reports in that area as well. So if I was a true battery scientist, I would probably tell you I'm most excited about the future of solid state or sodium ion batteries or lithium sulfur. You know, solid state, they overcome some of the safety issues. They're massively packed with energy. They can take up a smaller space and weight. So they're really exciting. Sodium ion, you know, potentially a really interesting replacement for lithium-ion. Sodium's more prevalent. It could be that they're more sustainable. It could be that they are great solutions, particularly for things like micromobility or scooters or motorbikes. So there's some really interesting and exciting work that's going on in the UK. I think, though, for me, the bit I really love, and it's probably harks back to my background as well, is around the circular economy solutions that are coming forward. And I don't just mean the pure recycling research that's going on, or the second life applications that are very creative entrepreneurs are looking at and developing. I do mean actually that all of it. So all of it from, end of life service centres where you take your vehicle to have your battery assessed or refurbished or maintained, through to how those batteries then get tested so that you can see the ones that need replacing in different modules, maybe different cells being replaced, and then to the point where they're dismantled and segregated so that you're actually getting really efficient recycling at the end of their life. The business models around the circular economy are so interesting. Even when you start to consider the logistics of all of it, how is it going to fit together really efficiently? And it's a massive question mark. When I read articles about recycling and end-of-life batteries, maybe it's the engineer in me, but I just actually start to get excited, because normally when you're looking at recycling, if you look at things like recycling of cardboard, there's not much value in it. Same really with plastics. But with end-of-life batteries, there's definitely very expensive materials in them. And that's a great driver. The transport at the moment alone of transporting something to Belgium, a battery at the end of its life to Belgium, where the current recycling sort of infrastructure lies, is huge. So I know there's a business model here. I know car companies are really motivated in this space. And I know logistics companies that work with the car companies are really motivated. And it's like, we've got so many of the elements needed to actually provide really robust solutions. And I think it's one of the areas in the last 4 years that has gone from being very little there to with a few people doing very specific things to massively energized. So many of the conversations I have at the moment are around circular economy solutions for end-of-life batteries. So I've known the team behind this show for a while. I know that they've previously run a very high quality show like this in Europe. And for me, the UK deserves a really high profile, technically competent and exciting show. So the reason I'm involved is because I think this is the one that really can become a leader in the UK. That's not to say there aren't others, because there's lots of different EV and battery events that go on through the year. But I'm really excited about this one. I think there's something that the UK needs that really showcases the technologies that are coming forward. So really pleased to be here supporting and sponsoring. And I do hope people can take some time to go to the Innovate UK, the Faraday Battery Challenge Lounge, and spend some time looking at the videos that we've got running there, and just immersing themselves in battery technology this year. Also difficult with COVID, but keen that the event is live, and I'm really delighted to be there in person. So yeah, you did prime me for this, thank goodness. There's a few sort of historical figures that I absolutely adore, people like Maya Angelou and Eleanor Roosevelt and her work with the UN Declaration of Human Rights. But actually, sometimes the people I really like to talk to are the ones that nobody really knows, that have worked so hard and changed the world. So as an engineer, Sir Frank Whittle is somebody everybody sort of knows about as an engineer, the inventor of jet engines. But behind him, in a laboratory somewhere, there's a guy called Dr. Leonard Bessemer File, and he actually was developing something called mnemonics, and they're the light alloys that are needed for the jet blades to actually work. And I'd love to just have a conversation with him, somebody who hasn't had great accolades and medals and recognition, knighthoods and everything, to really understand just the level of detail of trying to work out how to create a metal that could understand and withstand jet engine temperatures and jet engine stresses and strains. Yeah, I would like to have a really good, probably rather geeky metallurgist chat around mnemonics.